Have you ever wondered what existed before the Big Bang? Most people picture it completely wrong, imagining a dark, empty void waiting for a spark. Even scientists themselves are locked in fierce debate over this very question. By the end of this video, I will shatter 6 of the most common misconceptions you've probably never questioned. Close your eyes for a second and picture the Big Bang. What do you see? Most people imagine a giant bomb detonating in the middle of a dark, empty void with stars and planets flying outwards like debris. But that picture is completely fundamentally wrong. The truth is that space itself didn't exist before the Big Bang, and it wasn't an explosion of matter at all. In fact, the entire universe isn't expanding into anything. It's the fabric of space itself that is stretching. And this confusion is so common that a 2015 survey by the Pew Research Center found that 51% of Americans believe the Big Bang was an explosion that happened in pre-existing space and time. Think about it like a balloon. When you blow up a balloon, the surface stretches. But the rubber isn't exploding outward from a single point on the outside. A point on the surface doesn't see itself flying away from a central location. Instead, every other point just gets farther away as the rubber itself expands. Now, apply that to the cosmos. A faint hiss of microwave radiation fills every corner of our sky, a leftover echo that isn't a remnant of shrapnel, but rather the stretched-out light from the universe's incredibly hot, dense past. This cosmic microwave background wasn't discovered by someone looking for it. In 1965, Arno Penzias and Robert Wilson at Bell Labs in New Jersey were trying to eliminate a persistent static from a radio antenna, even going so far as to clean out pigeon droppings, before realizing the noise was actually the afterglow of creation. That background radiation is the proof that our universe was once a scalding, opaque soup, and it has been cooling down while space has been stretching ever since. A journey that hasn't seen a star explode dangerously close by for 4 billion years. So, if you think of the start as a sudden expansion of a region that was already sitting in some empty room, you're imagining a warehouse with a bomb in it. Instead, picture a tiny speck of space-time that begins to stretch, and as it stretches, it carries all the energy and potential for matter along with it, creating the very dimensions of length, width, and time as it goes. It wasn't an event that happened in space, it was the event that created space itself, moving from an intensely hot, dense state into the vast, structured cosmos we see when we look up at the night sky. The word explosion is a trap, leading your mind to a fireball bursting through a pre-existing void, so a more precise term to use instead is the early expansion epoch. When you hear someone call it a bang, you now know they're using a nickname for something far stranger, an expansion of nothing into the stage where everything would eventually play out. So, if this wasn't an explosion that tossed matter into a void, then what does that mean for the very idea of time before it all began? Most people assume that before the Big Bang, there was a long, empty stretch of time, quietly ticking backward into eternity, waiting for something to happen. We picture a cosmic clock already running, with before being just another set of moments we could rewind and rewind forever. That intuition is the second mistake, and it feels so obvious that we never question it. Yet time is not a stage that exists independently, it is a dimension woven into space itself, and it was brought into being with that initial expansion, J. Brian Pitts, a philosopher of science at Cambridge, argues that asking what came before the Big Bang is a category mistake, like asking what lies north of the North Pole, because time only exists within the universe itself. So the word before has no meaning if time itself did not yet exist. In 1927, Arthur Eddington coined the arrow of time to describe time's direction, but in the Friedman equations that model our expanding universe, the time variable can be mathematically cancelled out right at the singularity. If you plug the equations in, time loses its footing entirely, and the question turns into nonsense before you can even finish asking it. Stephen Hawking and James Hartle proposed something even more radical in 1983, the no-boundary proposal, published in Physical Review D, suggesting that asking what happened before the Big Bang is like asking what is south of the South Pole. There's no edge to point to. Hawking's colleagues attacked him fiercely because this idea erased the need for a creator altogether, and he faced the kind of professional backlash that most would try to avoid. The real punchline is that the very question you're asking is a ghost built from an intuition that has nothing to do with reality. We tend to picture the singularity as the ultimate beginning, a single, impossibly dense point where space and time first switch on. That mental image feels so natural that most of us never question it. Yet the term was forged not as a description of a real place, but as a warning sign from a set of mathematical theorems. In the 1960s, Roger Penrose and Stephen Hawking proved that any universe following Einstein's general relativity must trace back to a state of infinite density, a point where the known laws shatter. But here is where the story gets genuinely unsettling. What if that infinite point was never actually there? What if the singularity is just the exact spot where our equations collapse, not the physical edge of existence itself? Modern physics has begun to suspect that the classic singularity might be a ghost, an artifact of looking at the cosmos with an incomplete map. That suspicion gained real weight when researchers at the University of Oxford and the Clay Mathematics Institute started pushing on the problem from a quantum angle. Their work, published in Physical Review Letters, suggested that time itself might lose all meaning before the Big Bang, and that a quantum mixture of different spacetime geometries could replace the singularity entirely. Think about what that means. Instead of a single starting point, you get a blur of possibilities where the concepts of before and after simply dissolve. Then a team at the University of Pennsylvania, led by Eugene Lim, ran quantum modeling that reached an even more radical conclusion. Their 2018 study indicated the universe may have emerged not from an infinitely small, infinitely dense seed, but from a prior quantum spacetime where the whole idea of a sequential order breaks down. So when we say singularity, we aren't naming a thing that exists, we are naming the limit of what Einstein's math can describe, a boundary marker rather than a destination. The real twist is that the singularity only appears because our equations reach a point where they stop working, not because they've found a final answer. It is less like discovering the edge of the universe and more like watching a map tear at the edge of the known world, leaving a blank space that says, here, the rules change. And that blank space has a strange effect on us because our brains desperately want it to be a starting line. What if the starting line is an illusion? A consequence of the fact that we are trying to describe a quantum event with classical tools. The emotional weight of this idea lands hard. Everything we thought was a concrete beginning might be nothing more than a mathematical dead end, a place where the equations simply refuse to go further. If the singularity is not a real point in space and time, then the whole story of a moment of creation needs to be rewritten. And we are left holding a question that feels both thrilling and dizzying. What do you do when the beginning itself turns out to be a placeholder for everything we do not yet understand? You have probably heard of Roger Penrose, the Nobel Prize-winning physicist, and his bold idea of a cyclical universe. It is a seductive theory because it promises an eternal rhythm of cosmic death and rebirth, eliminating the need for a singular beginning. Penrose calls this conformal cyclic cosmology, and he suggests our universe is just one on in an endless chain of universes. He even points to specific evidence in the cosmic microwave background, the afterglow of the Big Bang, as proof. In 2022, Penrose and mathematician Krzysztof Meissner from the University of Warsaw announced they had found 11 anomalies in the Planck satellite data. These anomalies, which they named Hawking points, are essentially bright spots that they believe are the lingering signatures of supermassive black holes from a previous universe. Penrose, then 90 years old, boldly told The Guardian that this was the strongest evidence yet that the universe is cyclical. It sounds like a monumental breakthrough, and many online communities have embraced it as a proven fact. But hold on, the scientific community has greeted these claims with fierce skepticism, and the story is far from settled. The so-called Hawking points are not widely accepted by mainstream cosmologists, who argue they could easily be statistical noise or artifacts of the data analysis. A more fundamental problem comes from physicist Sean Carroll at Caltech, who points out a stark paradox based on thermodynamics. Since entropy or disorder must always increase, each cycle of the universe would have to be longer and more diluted than the last one, meaning you can never perfectly reset to the beginning. This creates a crushing problem. If the cycles stretch out indefinitely into the future, then looking back, there must have been a first most ordered state. The concept of a definitive start becomes unavoidable, directly contradicting the idea of an infinite repeating loop. So while the idea of a cyclical universe is intellectually thrilling, the reality is that it remains a highly controversial hypothesis, not an established fact. It is a beautiful mathematical dream, but the physics world is still far from reaching a consensus on its validity. So, what was actually there before the Big Bang? People keep asking that question as if they expect to find some kind of cosmic debris, a pile of leftover matter waiting to be lit. But what if the answer isn't a thing at all, but something far stranger that breaks every rule we hold on to? The truth is, our familiar ideas about substance and existence completely fall apart when you approach the edge of reality itself. Let's dig into what physicists mean when they say the beginning wasn't a beginning at all. The problem starts with the word something, because we instinctively imagine a physical object, like a tiny seed or a dense ball of fire. But in the 1980s, physicist Abe Ashtekar, Carlo Rovelli, and Lee Smolin built a theory called loop quantum gravity that turns that picture upside down. Instead of space being a smooth, continuous fabric, they describe it as a network of discrete quantum loops. And in that framework, the Big Bang isn't a moment of creation. There could have been a contracting universe before it, one that collapsed without ever reaching an infinitely dense point. And that changes the entire question we're asking. So, what exactly does that collapse look like, and how does it lead to everything we see? In 2006, a team led by Ashtekar with Tomasz Pawlowski and Param Singh published a simulation in Physical Review Letters that showed a completely different origin story. They described a universe that contracts down to an enormous density, about 10 to the 93 kilograms per cubic meter, and then, instead of ending, it bounces. Quantum gravity creates a repulsive force at that extreme pressure, and the universe rebounds outward in what they call a big bounce, so the singularity disappears entirely. That means our cosmos might just be the latest phase of a much longer cycle, one that has been contracting and expanding for eternity, and that's a dizzying thought. But even this bounce isn't the only possibility, because other physicists look at the problem from an entirely different angle. There's also the idea that our entire universe is just a bubble in a much vaster multiverse, where different regions undergo their own bangs and bounces. Theoretical physicist Lee Smolin even proposed something called cosmological natural selection, where each black hole spawns a new universe, much like Darwin's evolution selecting for success over time. So, what was before the Big Bang? It could be a parent universe, a different vacuum state, or a set of laws we can't even comprehend, and that's exciting, but it's not the end of the story either. What if the deeper issue is that we're using the wrong language, and before doesn't apply at all? Physicist Julian Barbour, the author of The End of Time, argues that time itself doesn't exist as a flowing river, and it only emerges from the movement and change of material objects. According to his model, if there's no matter structured in a temporal way, then the concept of before is simply meaningless, just like asking what lies north of the North Pole. All of our mental scaffolding, the stuff, the space, the sequence of moments, it all crumbles when you approach the quantum boundary of reality. So, what are we actually left with, and how can science ever test such bizarre ideas? You might assume that the Large Hadron Collider and our most powerful telescopes can simply peer back to the very first instant and observe everything directly. But that belief shatters when you look at the actual numbers, because the energy required to test our ideas about the beginning of everything is completely beyond us. Back in 2012, the LHC at CERN confirmed the Higgs boson, a triumph that opened the door to studying the universe's earliest states. Yet to probe the Planck epoch, we would need an energy scale roughly a quadrillion times greater than what the LHC can even produce, a gap that current technology cannot possibly bridge. Do you realize what that means for our grandest machines? The LIGO and Virgo observatories have detected nearly 100 gravitational wave events since 2015, giving us a new way to test Einstein's gravity under extreme conditions. These detectors even let scientists search for possible echoes of gravitational waves that might have survived from before the Big Bang, if a cyclic universe is the correct picture. But that is an indirect clue at best, not a direct observation, and it rests on assumptions we cannot yet verify. Here is the honest and humbling reality straight from the experts at CERN, who stated in their technical reports that recreating the conditions at 1043 seconds would demand a collider with an energy of about 1016 TeV. The LHC, by contrast, tops out at just 14 TeV for proton collisions, and nothing on the drawing board even comes close to that monumental figure. So where does that leave all the bold headlines claiming we have found what happened before the Big Bang? The American Physical Society, summarizing the scientific literature up to May 2024, confirms that no experiment has directly or indirectly verified any single theory about what preceded our universe. Every model on the table remains a mathematical conjecture, built on the unproven assumption that our visible cosmos is part of something larger we cannot observe. That means we are not holding instruments powerful enough to settle the debate, but a set of sophisticated mathematical moves played on a board we cannot fully see, waiting for a breakthrough that may never arrive. So you want to think like a scientist when someone claims they know what happened before the Big Bang. You need a filter, not a feeling. Let me hand you 3 practical tools you can use immediately, starting with how to organize the main theories so they don't blur together. Write down the 5 core ideas: the Big Bounce, where a collapsing universe rebounds, Penrose's cyclic cosmos with endless eons, the bubble multiverse floating in a larger space, Alan Gough's eternal inflation that never stops, and the Hawking-Hartle proposal where the question of before simply disappears. Then challenge each one against 3 columns. Does it require a start point? Can it be tested? And what math supports it? Your second tool is about checking whether a claim is real science or just a story dressed up in space words. Demand observational evidence that a telescope or detector could actually measure. Ask if the theory is falsifiable, meaning there is an experiment that could prove it wrong, just like Penrose's idea stands or falls on finding those Hawking points. Then hunt down the peer review, because a paper in physical review letters carries weight while a blog post carries none. Finally, look at who wrote it, because respected physicists like Lee Smolin or Abhay Ashtekar have institutional homes, not just viral YouTube channels. Now take every fact you learned earlier and push it through that filter to see how fragile each conclusion really is. That famous story about the cosmic microwave background being mistaken for pigeon noise is a beautiful accident, but it does not prove what happened before time began. Those quantum gravity models suggesting a bounce might be elegant mathematics, yet they remain untested predictions rather than established truths. The key habit is separating what scientists say could be true from what they have actually demonstrated, so you avoid the trap of treating a hypothesis as if it were a photograph of reality. Your belief that we have the tools to answer everything is now probably shaken, and honestly, that is a healthy sign. Science works best when it honestly admits, "We do not know yet," instead of pretending certainty. So, how does it feel knowing you are just a small part of a mystery that is far bigger than any single discovery? So you ask, what came before the Big Bang? After everything we have explored, the most honest answer science can offer is that we simply do not know, and that uncertainty is far more thrilling than any made-up certainty. We have seen how our everyday words like explosion, time, and beginning crumble when we try to force them onto the origin of everything. It turns out that science is not about having all the answers, but about being brave enough to admit when we have reached the edge of our understanding. Consider this strange fact. A 2015 survey by the Pew Research Center found that while 68% of American adults believe the universe began with a Big Bang, the vast majority of them also believe God played a role in that process, with only 33% accepting the purely scientific explanation. This shows how easily we blend our deepest hopes and faith with the cold, hard equations of physics, often without even noticing the conflict. The physical universe operates on its own rules, indifferent to our need for a plan or a purpose, and our desire for a comforting narrative can often overshadow the beautiful, stark reality. Yet this very discomfort, this tension between what we feel and what we measure, is where the real intellectual adventure begins. Do you feel that shift happening inside you right now? The question you asked at the start has transformed from a simple request for a fact into a profound acknowledgement of the vast, silent mystery that surrounds us. We are a small part of a puzzle that may be too large for our minds to fully grasp, and that is the most humbling and wonderful thought of all.